Yeah, welcome back to the Industrial Ethernet Week. As I mentioned in before, we are now focusing really on products, on real products to be soldered onto the PCB, high performance products which increase or support you to miniaturize your devices. And you can be sure that we have innovations for all kinds of products, from single pair Ethernet as well as from circular connector, RJ45 comparable connectors, as well as for PCB terminal blocks. So we cover during the next couple of minutes really a full range of all those different interfaces. And right now, I would welcome my colleague Marian Dümke, who will take care on the single pair Ethernet products.
Yes, so welcome everyone to the Innovative Connectivity session. So my name is Marian Dümke. I'm the Global Product Manager for our T1 industrial product family for single pair Ethernet. And in my part of the presentation, I want to focus on all the products around single pair Ethernet. We have already heard a lot this morning about single pair Ethernet. What is SPE? What is the status of the standardization? And what about the readiness of the technology? So, and we will focus on the connectivity. So, but before we start looking at real products in detail, I brought you some slides with some basic information about the connector system. And so, first of all, the entire connector system is standardized according to the IEC 63171-6. So this was the first connectivity standard for single pair Ethernet, already published in January 2020, so it's more than 2 years ago for industrial applications. And the beauty of this standard is that this standard covers all variants from IP20 to IP65-67. And that means in detail that we have the standard IP20 version for cabinet applications, and we have different M8 and M12 versions with different locking mechanisms, the well-known screw locking, push-pull, snap-in, and different quick locking mechanisms. And we have a special version, a hybrid connector based on an M8 form factor. And so this connector has separated power and data pins, so in total 4 pins, to transmit even more power. And so the technical specification of this connector system is as follows. So we will start with the mechanical performance. So we have chosen a typical Ethernet interface design for this connector. That means the plug version, so the cable connector is designed as a plug version, and the device side as a socket version like we know it from standard industrial Ethernet. So then we have all the IP ratings from IP20 up to IP65-67. So we can achieve 1,000 mating cycles for the IP20 version and several hundred up to 500 for the screw versions or for the IP65-67 versions. And we can cover an American wire gauge range from 28 up to 22. We can cover a temperature range from -40 degrees up to +85 degrees. And the whole connector system is approved to the railway or transportation standards. So it's shock and vibration proof to very hard requirements. So, so the electrical performance of this whole connector system, so the whole connector system is specified for a transmission speed up to 10 gigabit per second. So we can cover all the different IEEE standards from SPE from 10 megabit to 10 gigabit per second with only one connector. So it's made for rated voltage up to 60 volt, which came from the SPE standard. And we have a rated current of 4 amps at 60 degree ambient in temperature with AWG22. The connector is designed for voltage proof of 1000 volt DC pin to pin and 2.25 kilo voltage DC pin to ground. So the whole connector is made out of stainless steel. So we have a very good shielded connector, a 360 degree EMC shielding. And this means category E3 in the standardization. So, and this was a short overview of the technical specification of this connector standard. And now I want to take you with me. So we will go over to the real products in our product section here in the HARTING forum, where I have prepared all the different versions of this IEC 63171-6 standard. And we will start with our single per Ethernet ecosystem, which we explained this morning. So, and at this wall, we can see all the different single per Ethernet versions we have in this standard. So first we have the IP20 version. So the IP20 version is available as a overmolded patch cord or a field attachable version with crimp contacts. So this product is already available and was launched 2 years ago in 2020. And we also add terminal blocks for single per Ethernet for low performance application to our portfolio. So this terminal blocks will be available in the second quarter of this year. So on the next plate, we have all the different M8 versions which are available. So we have the standard version M8 with screw locking, the well-known screw locking from the industry. We have the push-pull locking mechanism, so quick locking mechanism, and we have the M8 hybrid version also with a screw locking mechanism. So then we have the M12 versions, which is the connector standard in the industry today. So there we also have 2 different locking mechanisms. We have the screw version and the push-pull version, and different device sites, and we have also different housing sites for the device. So, but this we will take a closer look in a few minutes. And so a really nice update. So, and this is the ongoing project of the idea of the hybrid version of the M8, is that there is a new standard in progress. This is called the IEC 63171-7, and this standard includes 7 different codings for M12 hybrid versions for 2-phase and 3-phase systems up to 360 volts and 60 amps in IP65, IP67. So this standard is quite new. The project started in the middle of the last year and will take approximately till the end of this year, but this is really a really nice development of this hybrid idea. And now we want to take a closer look, a detailed view on the product and the system. So, and therefore we go over to our detailed view box. So, and the whole connector system we developed according to the standard is based on this small data container. So this small data container is a universal data container which fits into the various housings. So we have in all the different variants every time the same insert. So we can see it here for the IP20 version. So it's the same insert, and as well we can see it at the M12 versions. We have also the same insert. So and this M12 version is also launched soon in February, so within the next weeks. So and this makes it very easy to create new connectors because we have always the same insert and can very easily integrate it into new form factors and as well in different styles in the next years. And we have a high use of common parts, and we have always the same quality. And this whole data container is specified for 10 gigabit transmission. And we have different device sites. So these are M12 device sites, which can also be used for IP20 applications because we have the same standardized mating phase, and we have in all the device sites the IP20 locking mechanism included. So this means even if this connector is mounted in an M12 housing, so you can always insert the IP20 version and can unlock them very easily. So it's a very nice feature. So we will launch these products in different heights, so from 8 millimeter up to 12.5 millimeter. And so these versions are compatible with the standard heights of the M8 and M12 products which are available in the market. This, for example, is for 12.5 millimeters. This is fully compatible with the THR portfolio of HARTING. This is 8 millimeters. This is also a very common height for M12 connectors. And we have also angled versions. And this is all based on our building block system and our modular system. And we have also a lot of different housing versions. Also, is everything based on existing designs of our M12 so that we have a common look and feel and that we can reuse all the existing parts. Yes, so that was it from me. That was a short overview about the product range of single pair Ethernet, what is already available and what is coming within the next months. And I hope you enjoyed this short overview, and I give it back to Joachim.
All right, many thanks, Marian. So we really see that a lot of products here are available today and are coming in the future. And the variants will be fully enhanced from standard connectors to hybrid connectors to different sizes. Very interesting. I found, by the way, the M12 hybrid connector for single pair Ethernet in the future, because especially as just two data contacts are used for single pair Ethernet, they are the perfect choice to create small-sized hybrid or one cable solutions in the market later on. Okay. Of course, there is a lot besides single pair Ethernet. Yeah. So as I mentioned in the beginning, the standard Ethernet is everywhere today in the industry, in machines, in transportation, in robotics. A lot of the devices here, from sensors to converters to switches, are used. And for those Ethernet connectivity, there is a lot of room, let's say, to create innovative new solutions. And today, as we have the PCB design, we will have a focus on how we can make those Ethernet devices even better. And I would now switch the view to the standard circular connector. So M8, M12 is a big range of HARTING of Ethernet connectivity. And therefore, I have brought with me my colleague, so Matthias Domberg. Welcome, nice you are here. Matthias is a product manager for the circular connectors within HARTING. And now, Matthias, the stage is yours. Thank you very much.
Yeah, good morning, Joachim. Thank you for the nice introduction, and welcome everyone to the next, I hope, interesting product session for you. And yeah, I would like to give you a short overview about our circular connectors, and let me start with the products, especially for the Ethernet application. So HARTING offer a wide range of circular connectors, beginning from M8 up to M23 size. And with our product, we can address mainly data, signal, or power application. But the focus on my presentation today will be more or less Ethernet-related products. So here on the table, I have some products with me. So, for example, here you can see a typical M8 connector in a straight version, or we have also an angled version in this case. This is an M12 connector, but these connectors are more or less used for, let me say, fast Ethernet, for data transmission up to 100 Mbit. Here in comparison, can we see an M12 connector with the same technical specification as described for the M8 connector. And if you need connectors for the higher data transmission, you can also use this kind of connector. Is called X-coding connector. Here we have offer a solution for 1 gigabit, or also a solution up to 10G in a straight version, or also in an angled version. So, but besides these standard components for the PCB, we developed a lot of other interesting products, and one of these interesting new products is the M12 transformers. So let me explain what does it mean. So on the following slide, can you see a typical application for the PCB? This PCB layout is called discrete design and describes a solution where all needed components placed separately on the PCB. In this case, from top to down. So we have the Ethernet chip, the resistors, we have the capacitors, following by the transformer unit, and finally the M12 connector. On the right side, can you see the schematic diagram as well? Important to know is every port on this PCB needs this component setup. So you can see we need a lot of space on the PCB for those components. This means Ethernet chips, resistors, capacitors, and transformers. But one of the main components on the PCB is a transformer unit. So the transformer unit ensures galvanic insulation and therefore protects the Ethernet chip from inputting external voltages. Secondly, the transformer contributes to improve the signal quality. So on the next slide, can you see the HARTING solution? So what we did, we removed the transformer unit and some other electronic components from the PCB and integrated them into the M12 connector. So this idea is not really new. We took this idea from the now approved IP20 RJ45 jack and implemented it in our M12 connector. So now we can offer a robust solution for an IP65-67 application environment with a known M12 interface. A further important benefit for our customer is the aspect of space saving. So as you can see here on a slide, each M12 connector with integrated transformers allows to save approximately 30% space on the PCB. That allows the customer to design their devices much more compact as they're doing today. So you can see this huge potential of space saving in a direct comparison here on this slide. Please have a look to the PCB on this slide. There you can see a solution in a discrete design, and beside of this, our new solution with integrated transformer. Okay, now some words to the products. So as you can see here, this is just an example. This is something what we call M12 with integrated transformer. The bottom part of the connector, we have the contacts. In this case, this product is suitable for surface-mounted technology. So this means this product is suitable for the reflow process. So furthermore, in the bottom part of this connector, we have the integrated transformer unit. And here we have the separate shielding. And in front of the connector, we have the mating phase. Here, in this case, the decoding. This product family is available for decoding in a straight version, also in the angled version decoding, in the X coding up to 1 gigabit, also in a straight and angled version. And finally, this version is also available up to 10 gigabit. All these products are available with power over Ethernet or without power over Ethernet, depending on your application. So, finally, I have a nice application with me. This is an application sponsored by the company CGF nearby Frankfurt, and this company developed switches for public areas. So, and this name of this product called Glen, and this customer decided to use our product because they saw the huge potential of space phasing, which offers our products in this case. So here, in the top of the device, you can see the customer solution, and they implemented our M12 connectors in their design. So I hope you enjoyed this session. This was just a quick, and a short overview about our products. Please let me know if you have further questions. Send me an email or whatever. And thank you for your attention and stay healthy.
Great. Many thanks, Matthias. So a very, very interesting solution. We can say it's not something completely new or unsafe. This is just the smart transfer of a solution which is already known and proved for RJ5 connectors, RJ45 connectors to the M12 world. Very nice. So if you have questions to Matthias, what I always find is a very smart way is just to contact him by LinkedIn and to get in touch with him. Okay, coming now from the IP65, 67 world down into the cabinet to the IP20 world. We all know that industrial Ethernet, or let's say the dominating Ethernet for interface for industrial Ethernet, or Ethernet in general, is the RJ45 connector. The RJ45 connector was the first connector for Ethernet. It was designed for, I would say, telecom applications, enterprise applications, but nevertheless, it found his way into the industry. If this is, from today's point of view, still good and state of the art, and if we think about vibration and shock and so on, that's a different question. But also here, HARTING has a very innovative solution. And by this, I would like to hand over to a youngster, a product manager, Maximilian Rohrer, to continue.
Thank you, Joachim. So, hello to all the viewers out there. I'm very happy to be on your screen today. When we speak about innovative and miniaturized connectivity, we need to speak about this guy here. It's Captain iX. And before I go into details regarding Captain iX and the iX Industrial, I want to make a short time travel with you. Just think about RJ45. What comes into your mind? Often customers say, okay, we have limited performance, limited robustness, and the size is very huge. So we thought they need a new interface. And as Joachim just mentioned, the RJ45 comes from the telecommunication market. And there is no need of robustness. There is no need of very high performance as in the industry. So we developed the iX Industrial with a new standard, standardization which is according to the IEC. So you have the security to use an international standardized interface. And with this standard, we have millions of possible application possibilities. We have on the one side type A, and on the other side type B as codings. And as we are here in the Ethernet week, of course, we will take a closer look at type A. And when we see as well guidelines, I want to mention that we as well listed in the Geek E vision for the camera market, as well as in the Profinet. And here in the Profinet, we are since last year. So from now on, you can implement the iX Industrial in your device, and it can be Profinet certified. Let's come to the important question, why Captain iX is a real superhero. So there are 3 points. First of all, we have miniaturization. Second is robustness, and third is performance. And I want to show you these examples on real parts. So let's go over to the table and check the parts in real. So the first point was miniaturization. And when we see now the difference between iX Industrial and RJ45, you see how much it mentioned. So it's more than 70% smaller. And the best thing is, you have as well a minimized pitch. So we can see it here very good. We have on the one side 5 iX Industrials, and on the other side 3 RJ45s. And you see how much decreasement of size is possible with the iX Industrial. And so there are new solutions, new possibilities for design the iX Industrial in your device. The next point was robustness. And when we check regarding robustness, we will see now the points which make the iX Industrial so robust. We have on the one side THR shielding pins, which leads to very high retention forces onto the PCB. Furthermore, this is one advantage of the plug. We have, it's very, very small, but they are there, 2 metal locking clips. So when we now made it clicks as well. It made an audible click. Perhaps you hear it, otherwise you have to trust me. And we have a very robust connection between jack and plug here. And this is as well due to the small tolerances which are in the standardization. And as well due to the small tolerances, we have a very high shock and vibration robustness, and up to 5,000 mating cycles. So we had miniaturization, robustness, and the third is performance. And we tested the iX Industrial, and the whole portfolio of iX Industrial is according to Cat6a performance. So future-proofed for your device. Furthermore, we have a 360-degree shielding from the jack and the plug. So we have a very high EMV robustness in the end. And I also want to give you a short look at the portfolio. Very short. If you have more interest in this, just check our website. First of all, we have all kind of different jacks. So you see here an angled horizontal flag, a jack, angled vertical, or a vertical jack. So for your designers, they have all freedom to design the device as they want. Furthermore, we have different plugs. So we have, for example, the AVG 22 to 28 IDC contact, but as well a solder version. And if you're interested, for example, in cable assemblies, we have them as well. For example, IX to IX or IX to RJ45. Everything what you want, what your wish is, we can realize. At this point, I also want to make a short sneak preview. So what is in the future with IX Industrial? What's going on there? And there I want to show you, for example, the angled plug. So we can see here now the angled plug. As you see, there will be two different solutions, downwards as upwards, and especially for small applications, it's a perfect fit. Furthermore, perhaps some of you know the HARTING push-pull. And now I will show you the little brother of HARTING push-pull with all the advantages. It calls the mini push-pull. And as well, here we implemented the IX Industrial. You can see it here. And while we speak the whole time about IP20 solutions, the future will have as well a IP65-67 solution with IX Industrial implemented. Furthermore, in the future, there will be an IP20 push-pull. So you see it here as well. Here it will be an overmolded version as well as field attachable. And the genius thing is you can unlock it with a latch here or directly on the plug. And the good thing is for very high density applications, it's very good because you can really put them very close together. So that to the sneak preview. And of course, I also brought you some examples, some applications with me. At first, I want to show you the switch, the IX Industrial switch. So we have here the IX Industrial switch and on the other hand, an RJ45 switch. Both have 8 ports, but when you see the measurements, you see how much smaller the IX Industrial switch is. So as well, the IX Industrial switch is a perfect solution for small spaces. And a big thanks to my colleagues, the HAN ID colleagues, we have as well the IX Industrial in a HAN ID module. And it is the first Profinet certified device. So as I said, as well for Profinet applications, the door is open now for IX Industrial. And the last application is the application from Beckhoff. It's regarding the XTS transportation system and intelligent transportation system. So before, you have to imagine here were 4 RJ45s on it. With these 4 RJ45s, they could transmit 4 Ethercat channels. With IX Industrial now, we have 8 ports at the same size, and now the interesting point comes. With this 8 ports, Beckhoff was able to transmit 16 Ethercat channels. So each IX Industrial is able to transmit 2 Ethercat channels. So overall, it's an increasement of 300%. That's all from my side. I was very happy to present you this. And now back to Joachim. Thank you very much.
Yeah, thank you very much, Max. Very, very interesting, a very, very innovative interface. And I think requirements change. They change over years and years and years. In the beginning, there was just the RJ45. Afterwards, the IP65 interfaces like M8, M12 were established for Ethernet. And now we are in a new decade where we also need to think about IP20 devices. Is the RJ45 still the right connector? I think all the companies I at least have visited, they always have the same opinion on this connector interface because each industrial company doesn't like it, but it's established and it's cheap. Yeah, but with the iX Industrial, as Max just informed, we have a very miniaturized, high-performance solution with an industrial robustness needed, and which is luckily also since last summer placed as an official P&O interface, which is a very, very important step. And I personally, if I would be a product manager for my converter or switch or whatever, and if I would like to think, okay, what can I do better for new devices, then my feeling would be, wow, with just this, using this connectivity, you can become so small, you can become so more reliable with regards to shock and vibration that it should really be a big thing for you. All right, great. So thank you very much for this. We have heard a lot about Ethernet connectivity with regards to connectors, but as we all know, for some applications with certain limitations, maybe also PCB terminal blocks are possible to use. And this will be the topic of our next presentation. And therefore, I would like to welcome the product manager for our wire-to-board connectors, Erich Dümke.
Yes, thank you, Joachim, for the nice introduction. My name is Erich Dümke. I'm the product manager for our half lexicon range, which is a wire-to-board connector series. And I would like to present to you today the applications and the cases where you can actually use the alternative of terminal blocks for Ethernet applications. Before I go into the details and the different applications possible, I would like to briefly put the terminal blocks again into the context of the Ethernet trends today. So first, as we have been discussing a lot, there is this trend of bringing Ethernet to all the levels, down to the field level and up to the cloud level. And this is also one of the points that we are addressing with the single pair Ethernet technology in specific. And so we can say there is this very prominent trend of making a consistent infrastructure with one consistent Ethernet communication system. Now, when we are talking about the different applications in the field level, we are talking today in many cases about industrial IoT. So, for example, sensors and actors that are installed permanently in the field and need to be connected to make them more smart in today's world. And we can say that many of those applications, for them, it's sufficient to have lower data rates, such as 10 or 100 megabits per second. And we can say this is a parallel or an additional trend to the one in the past, where we had increasingly higher and higher data rates, beginning at several megabits per second up to several tens or hundreds of gigabits per second. So this is one additional trend where we can use lower data rates for applications in the field level. Now here the terminal blocks come into play, because with terminal blocks, as Joachim mentioned before, we can also transmit Ethernet, though in a limited way when compared to connectors, of course, but still there is some potential, especially for those permanently installed connections in the field, in the context of industrial IoT. So, speaking about our half lexicon range of wire-to-board connectors, we are going to enhance this and also introduce new products for use in Ethernet applications, specifically also talking about single-pair Ethernet. As you can see here on the slide, we will have a great range of variable products, so different contact pitches like 2.5 millimeters up to 5 millimeters, then one component solutions where you have a fixed product on the PCB, or also one pluggable that you can see on the bottom of the slides. Now, when you compare terminal blocks to connectors, of course, you will say, okay, a connector, it's really easy to connect. It can be operated by anyone, and it's really something that you need if you want to disconnect and connect the applications a few times. When talking about terminal blocks, of course, they are more interesting for permanent connections. But still, to make it easier for the operator to use them, we are introducing several different termination technologies that are very straightforward and very quick to use in the field. That being, on one hand, we have the push-in, where you just push in the cable. Then we have the IDC. There you do not have to remove the insulation because it will be cut by the connection established. as well as the spring clamp, which you can operate just using your fingers. So really something that we want to make easier to use in the field and more quickly. Now, just to demonstrate a few real examples, I have brought some samples with me. And here you can see basically the products from the slides. And when I look at one of the smallest products, you can really see it's compared especially with connectors like the RJ45. It's quite small and also very flat. So a nice way to also make the devices smaller, especially those where you have a cable gland going into the housing and then onto the PCB. Then we have also different pole counts, as you can see. So we have the single pair Ethernet, we have Profinet, and also the 4-pair Ethernet here with different color codings. So really, terminal blocks are known for their flexibility, and you can really realize many different applications and many different codings for all the different needs. So continuing with the slides, I can just sum up. We will have products for 1-pair Ethernet or single pair Ethernet, for 2-pair Ethernet like Profinet, as well as the 4-pair Ethernet. So as I mentioned before, terminal blocks can be interesting for many different applications in today's production facility environments. And when we look at this overview, for example, we can see there are different devices on the bottom level, on the end node or field level for the single pair Ethernet. And especially there, you can imagine that you can use small terminal blocks installed on the PCB to connect the cable to. But of course, I think every one of us has seen some kind of terminal blocks already somewhere in the field. So of course, there are some Ethernet applications that can also be used, or terminal blocks can also be used there in this context with data rates of 10 or 100 megabits. So going more into detail, which kind of applications are we actually talking about? When talking about the field level, permanently installed devices, we have sensors and actors, of course, but also specifically in the IoT context, we have lighting, for example. Lighting applications are usually installed one time, and they will be running for a very long time without the need to disconnect and connect them again. So especially when we have such a broad range of different connectors for Ethernet and SPE, these kind of applications are where terminal blocks can present a real alternative and one with different benefits, which I would like to summarize here. So, of course, as I mentioned before, they can be used especially well for permanent connections in the field. But also, we are talking sometimes about limited spaces or miniaturized devices. And if you can reduce the number of components, like a male and female part of a connector, you can, of course, also reduce the space needed for the device. So this can be a solution for miniaturized space-saving devices. Furthermore, it can be cost-saving opportunity because you reduce the number of components, and of course the terminal blocks are in many cases a little bit less expensive than connectors, for example, which of course are more optimized for higher data rates and for plugging and connecting again. Lastly, there is also the point I would like to mention of the color coding. As you have seen before, it's really easy to implement different color codings, different printings, for example, to realize all kinds of different application areas and devices. So now when we're talking about connectors, the data rates are very high, several gigabits per second, for example. For terminal blocks, they can reach, or we recommend them to use at 10 or 100 megabits. With the right optimization, and if there really is a focus on that, you can also achieve more than that. I have here included some overview over the different possible protocols. So when talking about the IEEE 802.3 protocols, several ones can be used. So 1 pair, 2 pair, 4 pairs. And of course, one part of that is also the power supply. So the devices in the field level have to be supplied with power. And as we have also heard several times already, there is a power over data line or short poodle. And there's also the classic power over Ethernet. So these we can also use to transmit up to 90 watts of power to the end device, also with terminal blocks. As I mentioned before, terminal blocks, of course, are limited in the data range, and we can implement different kinds of optimizations to optimize really the data capability. And here we're talking first about the PCB layout. So there are also different points here to make. So one would be compensating the different crosstalks between the differential pairs, or also optimizing the impedance profiles of the terminal blocks to optimize the return loss and insertion losses. And there have been some evaluations, and you can always come back to us if you need any recommendations for specific PCB layouts. The other area of optimization I would like to talk about is the shielding. So it might be necessary to add the shielding, and there are several ways to connect the shielding to the PCB or to the terminal block. One is you can use one dedicated shielding pin in the terminal block. This can look like this. So you also saw this on the slide or on the samples I showed before. But you can also use one additional single pole of the portfolio I presented to add to the terminal block and connect the shielding pin or the shielding of the cable. Another nice way to connect the shielding is with the cable clamp, as you can see here on the right picture. There you can also use this clamp to, on one hand, connect the shielding, but also to implement a strain relief to relieve the connection points in the blades, for example, of the IDC block from any mechanical stress. And lastly, if you're using a device with a cable gland where you put the cable directly through the housing onto the PCB, you can also use the cable gland to connect the shielding to the housing. So really a very broad range of different connectors or different terminal blocks where you can choose your perfect solution, specifically in the context of industrial IoT for permanent devices or permanently installed devices in the field, as well as to save some space or costs for miniaturized designs. Yeah, so thank you for your attention. This was the presentation for the terminal blocks, and I would now hand over again to Joachim.
Yeah, thank you very much. Thank you very much, Erich. Very interesting. So this was our last product session for today. I hope you have seen that HARTING really is, no matter if you are designing an IP20 device in the cabinet or an IP65 device somewhere in the field, HARTING has a huge bundle of very innovative solutions here. We have established interfaces where we put some additional gimmicks to make them more smart and innovative. We have new interfaces like the iX Industrial, and of course we cover future trends like single pair Ethernet also with concrete products. So one further advantage of HARTING to support you for the design in is our global sales team. So HARTING is not a company which is mainly dealing with distribution. Of course, distribution is a very important part for us, and there are many electronic skill distributors in the world. But HARTING is one of those companies who has in each different country, from China to US to Italy to Spain to wherever, we have own local HARTING subsidiaries with own product managers. So product managers really have a focus on PCB design. Yeah, so means whenever you have the need to get support for your design, just contact the local HARTING subsidiary, and there will be really specifically trained guys.